What I would like to talk about in this video tutorial is two software products that I've used in the past to document buildings for modeling purposes. There are two different products. One is to basically describe the building in a three-dimensional space, and the other one is recreate a geometrically correct image of the building. So, for example, the facade of the building, if you want to convert it to a drawing. So the first product I'm going to talk about is Microsoft Photosynth, which is a free software. You can download it from Microsoft website, and it needs you to have a Microsoft Live ID, like a Hotmail account or something. So the software will ask you to provide that account in the beginning. So what you do is you say that, okay, I want to start a new synth, and what you need to provide is all the pictures that you have taken of a building. So in my case, I have photographed a station, and now I've just selected all the photos. I've given a name. There are some tags and descriptions that you can also specify. And then there are a few other options in the software that you have to provide. But basically, all you need to do is select the pictures and then press synth. And what it does, it basically looks at each of the pictures, and just by identifying the overlapping areas in the picture, it is trying to recreate the three-dimensional space that the building is sitting in. So if you have taken you have taken pictures from the front of the building and the side of the building, it will try to figure out where the original picture was with relation to the other pictures. And in order to make a successful synth, you need to take as many pictures as you possibly can from the building. So the sync is now complete, and then you can see the result. So basically you can just use the navigation buttons and then browse around in a three-dimensional space and see your pictures as they had been taken in that area. And when you're looking at the picture and then you move the mouse around, you will see like a rectangle showing the location of all the other pictures in the surrounding areas. And basically, just by clicking on these rectangles, you can move around, and then you can go left and right, and basically the software will just transition from one image to another. And this is all done by the software, so you don't need to do anything while you are taking the pictures. All you have to make sure is that the pictures you are taking has enough overlapping areas, so the software would know how those pictures are related to each other. So as you can see, I'm roaming around in the area. I'm looking at various pictures around the of the station building. And now I've selected a picture which shows a detailed view of that plate on the front, and I can zoom in. I can see all the details from that single image. Now I'm moving to the left. Again, I'm seeing pictures from the side taken very close from the building. I have a picture where I have looked up, and I can look up in this three-dimensional space as well. Sometimes I have these rotating arrows when the software thinks that there are an image which was taken from the side of the building. Well, sometimes it works, sometimes it doesn't. And what you can see here is now the software was even able to integrate a picture that I've taken almost from inside the building, and I can use the simple zoom command to zoom into the picture. Probably this is zoomed too far in that it's not sharp enough. The next product is AutoPano, which is not free, just like the previous one, and this was originally designed to stitch photos taken for a panorama. So if you have nice settings and you have taken pictures by panning the camera to left to right or right to left, so you have individual pictures from like a nice valley, this software can stitch those pictures together. So but instead of taking a picture of a valley, what I'm doing here is I've taken pictures of a building and I'm trying to stitch those pictures together. As you can see, I have pretty much zoomed in onto the building, and I have taken shots from, let's say, top left going to top right, and then going one row below, and then panning the facade of the building from left to right, from top to bottom. And again, I haven't done. There are no special settings on my camera. All I have done is I made sure that there are overlapping areas in the adjacent pictures, so the software can see those overlapping areas, and then basically build up again a mapping of the picture, like how they follow each other. As you can see, the mapping is now done, so I'm now presented by the stitched image, which shows the whole building. It shows pretty much from a lot from the sky. You can see that the software has already suggested that should be using a planar projection. So basically projecting these images to a plane instead of a cylinder. For example, this is how it would look like if this would be projected to a cylinder. But because of the subject is a more, I mean, the facade is a two-dimensional object, it should be projected to a planar plane. And now I have a few options to edit this image. Of course, I can crop the image, so I can drop the areas that are not complete, or I don't need too much of the sky. And what is really interesting about this is turning that feature on. I can see how the individual pictures make up this whole image. So now you can see that I have moved around. I have basically taken these images in the 3 rows or 4 rows, and the software just work out the connection between them. So what I'm going to do is I'm going to crop the areas that I'm not interested in. So I don't need too much of the sky, but I want to make sure that the whole building is visible in the picture. So I'm just cropping some areas on the top and the left and right. And then I accept the changes. Then the software will compute the remaining areas again, and now I have the cropped image. There are some options to change on the colors. So for example, if I had not used a manual setting, so I've taken all the pictures on auto, I might ended up with, some pictures being brighter and some pictures are being darker, so I could use the previous option to correct the colors. And what I can do in this one, in the levels screen, is just to adjust the brightness and the light areas and the dark areas of the picture. So for example, I can enhance the contrast of the image by moving the left and the right sliders in. And what is more important, especially if you want to make a model out of this building, is that you make sure that your horizontal lines are horizontal and your vertical lines are vertical. So in this tool, what I'm doing is I am marking a few horizontal lines on the picture. So for example, the top of the 2nd floor, the top of the 3rd floor, and then I'm changing to vertical, and I'm marking the corners of the building. So by providing these lines on the picture, the software will be able to remove some of the distortion which is caused by the camera lens and this whole stitching process, which obviously takes pictures that are in different geometry. So I've now clicked OK, and again it takes some time for the computer process the image, but finally I have the geometrically corrected image. Now you can see that the horizontals appear to be horizontal and the verticals appear to be verticals again. And once you have done with all the settings, obviously you need to render the final result, which can take up to 20 or 30 minutes depending on your computer. So this video is not taken at original speed, so it had taken probably 15 minutes on my computer to generate the final image. This is another example. In the previous case I had a building which was on a big square, so I could be I took the photos quite far away from the building, and in this example this was just a narrow street, so you can see how the building just opened up upwards because I've taken the photo from quite short distance, and obviously the camera was looking up as I've taken the pictures from the second and the third floor. But again, by providing the vertical and the horizontal lines, the software is able to remove much of that distortion. So by looking at the final result, the image appears to be correct and not and doesn't have any distortion. So if you take this image and then you import it into, for example, CorelDRAW or any other software where you can create raster lines, you can basically trace that image, and that would give you a plan of how the building looks like, where the windows are, and some of the other features. Just looking at the final photo, the final rendered image. So you can see now all the details. The lines are horizontal and vertical. Now I'm zooming into the image. It takes some time to process the complete image. Obviously, it's probably around 26 megabytes and probably something around 30 megapixels. But you can see all the details even if I zoom into like 100% magnification. I can see all the intricate details in the brickwork and the rendering, and this actually gives you really high resolution image. So you can take this and print it to maybe all the way up to A1 or A0, and it will still give you all the sharp details and the accurate edges and everything you would need to do in order to turn it into a model. This is the final image from the second building. Again, you can see that it appears to be geometrically correct, but you can see that in case of the windows or the window frames, if you're looking at the windows in the middle, you will see the whole frame, the left side and the right side as well. But if you look at the one of the windows on the side, you will see that the walls or the plasterwork is blocking the view. So if you want to trace this image to create a model, you would need to trace the contours of the basically the window frame which is on the facade of the building. Again, now you can see all the details of the image, how it appears on the in 100% magnification. So again, you can print this in high resolution and it will be fine. Well, thank you for watching.